Hello everyone, I am Agnes Davidson of class 9S. Today we are going to find the measurements of a wire using a screw gauge. Before we move on to the measurement, let us look at the parts of the screw gauge first. This part here is the pitch scale or the P scale. It has both horizontal as well as vertical lines. And this part here is the head scale or the edge scale. It has 100 divisions from 0 to 100. And this is the part where we secure the wire or the object. The first thing we need to find is the pitch of the screw gauge. The formula for that is distance moved by number of rotations. We can see here that if we rotate the screw gauge one time, the distance moved is 1 millimeter. Now we will rotate it 5 times to get it clear. Now we can see that after 5 rotations, the distance moved is 5 millimeter. So the distance moved is 5 millimeter by number of rotations is 5, which is 1 millimeter. So we got the pitch of the screw gauge as 1 millimeter. The next value we have to find is the least count of the screw gauge, and the formula for that is pitch by number of divisions on the head scale. As we have seen earlier, the pitch of the screw gauge is 1 millimeter and the number of divisions on the head scale is 100. And so the least count is 1 by 100, which is 0.01 millimeters. The next value we have to find is the zero error. You can see here that the 0 on the edge scale aligns with the 0 on the P scale, and so we can take the zero error as 0. If in a screw gauge the 0 on the edge scale is above the 0 on the P scale, we take the value as positive, and if it is below the 0 on the P scale, then we take the value as negative. For example, if the 0 on the edge scale is 4 lines above the 0 on the P scale, we take the value as plus 4, whereas if it is 4 lines below the 0 on the P scale, we take the value as minus 4. Now we will move on to the measurement. So the first thing we need to find is the diameter of the wire. So we will tighten the wire in here. We have to tighten it till we hear a click. Make sure that you rotate this part only, as if you rotate this part, there may be some error in the reading. Now, for the first thing we need to find is the pitch scale reading or the PSR. As you can see here, after we have tightened the wire, we can only see the 0 value on the pitch scale. So we get the PSR as 0. Next, we need to find the head scale reading or the HSR. For that, we need to find the value on the head scale which aligns perfectly with the horizontal line on the pitch scale. And in this case, you can see that the value is 35, and so the HSR is 35. As we've got the PSR and the HSR, now we can find the total reading, which is the diameter of the wire. The formula for that is PSR plus HSR into LC, which is 0 plus 35 into 0.01, and we get the total reading as 0.35 millimeter. Now, to reduce the risk of error and get the most accurate result, we need to repeat the measurement at least 5 times and then take the mean of the readings to get the final total reading, which is the diameter of the wire. Now I've taken the reading 5 times and I got pretty similar results. Just remember that the PSR will never change. There may only be slight changes in the HSR. And after taking the reading, I got the mean as 0.35 millimeter, which means the diameter of a wire is 0.35 millimeter. We got the diameter. Now we will find the volume of the wire. The formula for that is pi r square L. So we need to find the radius and the length. To find the radius, we have to divide the diameter by 2, which is 0.35 by 2, and we will get a value 0.175. And since we are calculating it in the MKS system, we have to convert this millimeters into meter. So with 0.175 into 10 raised to minus 3. Here I have directly converted it, but you can also take it in the exponential form. Then we have to find the length, and as you can see here, the length of this piece of wire is 9.4 centimeter. So we have to convert that into MKS, which is 0.094 meter. Now, as we got the radius and the length, we can move on to the measurement, which is 3.14 into 0.000175 square into 0.094, and we get this value. And since this is a very small value, it would be better to write it in the exponential system. And so, we get the volume of this wire as 9.04 into 10 raised to minus 9 meter cube. So, in this experiment, we learned how to measure the diameter and volume of an object using a screw gauge. Thank you.
Good morning. My name is Sanjeev Kiran from class 9R. Today, I am going to present a project on Archimedes Principle. Archimedes was a Greek scientist, philosopher, engineer, mathematician, and physicist. He is regarded as one of the leading scientists in classical inquiry. A property of a liquid is that when a body is immersed in liquid, the liquid exerts an upward force on the body. This is called buoyancy. When an object is immersed in a liquid, the object occupies the space which was earlier occupied by the liquid. So, the volume of the body is equal to the volume of the displaced amount of liquid. Now, let's verify the Archimedes principle. For this, I will take a digital balance. And tie the rock to the balance. Then you can see the weight of the rock is 20 grams. Now let us slowly immerse the rock in the Eureka can. The weight of the rock decreased to 15 grams. This is because the water exerts an upward force called buoyancy. Now let's take out the rock. Now let's measure the water displaced amount of water. We can see the volume of the liquid is 9 grams. So, according to the Archimedes principle, the volume of the displaced amount of water will be equal to the volume of the solid. Thank you.
Good day to all. My name is Divya Nagar of class 9S. Here, I am going to do an experiment to show how to turn an iron maid into an electron magnet. For this, we will need an ammeter which has two knobs, one positive and one negative. Then we will need a rheostat which is used to control the flow of electricity. It is used as a conductor. Then we will need a key which is used to break the circuit and connect it back. Then we will need an iron film that we can show the magnetism effect. Then we will need a battery that would be in this experiment. After this, we will need copper wire which is insulated with a white sleeve around the copper wire and a copper coil which I have already coiled into, and it is also insulated and its ends is scrubbed out. Now let's start connecting the wires. First we should connect the positive wire to the key. Then we should take a copper wire and connect it to the key like this. Then we should take the rheostat and connect the other end of the wire to the lower base of the rheostat like this. Then we should take the other copper wire and connect it into the upper point, the rheostat. And take the other end of this wire and connect it into the positive end of the ammeter. Now, we should take another copper wire and connect it to the negative end of the ammeter. Then we should take the coiled copper wire and bind this together. Stop. Now we should insert the iron needle into this copper core. Now let's check if it works. Yeah, it works as the circuit is complete. Now let's pour some iron fillings. Now let's bring the iron nail near to it. Insert the key. And as you can see, there's a less amount of iron fillings clinging into the iron. So our experiment is done. Thank you.
Hello everybody, I am Rida of class 9. I am going to demonstrate an experiment on vernier calipers. Using vernier calipers, we can measure the dimensions of a given small material very accurately. This is a vernier caliper. It has a main scale in centimeter, which is exactly scale like the centimeter scale which we use. And a vernier scale, there are 10 lines marked on vernier scale. If the 0th line of vernier scale coincides with the 0th line of main scale, then there is no zero correction. In this vernier calipers, there is no zero correction. Next is to find the least count of vernier calipers. The formula of LC is equal to 1 main scale division divided by number of vernier scale division, which is equal to 0.1 divided by 10, which is equal to 0.01 centimeter. Now, I am going to measure the length, breadth and thickness of this rectangular block using vernier calipers and find its volume. To measure the length, the rectangular block is to be held like this between the jaws of the vernier caliper. Now, we have to take two observations. One is MSR and another is VSC. MSR is the reading on the main scale which coincides with the 0th line of the vernier scale. Here it is 9 centimeter. VSC is the line on the vernier scale which exactly coincides with any line in the main scale. Here, the 5th line of vernier scale is coinciding with the line in the main scale. So, the VSC is 5. Now, we have to find the VSR using the formula VSC into LC, which is equal to 0.05. Therefore, the length of rectangular block is equal to MSR plus VSR, which is equal to 9.05 centimeter. The experiment is repeated for 4 or 5 times, proceeding in the same way to minimize the error in the observation, and finally mean value of length is taken to substitute in the volume formula. Same way we have to measure the breadth of the rectangular block by holding the block like this, and the thickness by holding it like this. Now we got the length, breadth and height of the rectangular block. Therefore, the volume of the rectangular block is equal to length into breadth into height, which is equal to 9.063 into 6.236 into 1.266, which is equal to 71.55 centimeter cube. Thus, volume of any material can be found out using vernier calipers accurately. Thank you.
Hi all, my name is Agita Vinaya and today I am going to do an experiment to show that time period of a simple pendulum is directly proportional to length. This is a simple pendulum. This is the point of extension and this is the point of oscillation and this is the string. So as we all know, time period of a simple pendulum doesn't depend on the mass of the bob. Now, what do you mean by one oscillation? When this bob is in A position and when it moves to B, when it moves to C, and when it comes back to its first starting position, it is named as one oscillation. That is, when this bob is moved to point B, point C, and when it comes back to point A, it is known as one oscillation. So I am going to show you that time period of a simple pendulum is directly proportional to its length. Now, this point is known as a point of extension and this point is known as a point of oscillation. Now, the distance between the point of extension and point of oscillation is known as the effective width. That means this and this. These places between the point of extension and point of oscillation is known as the effective length. And the time taken to complete one oscillation, that is 1, 2 and fro movement of the bob. So the time oscillation means 1, 2 and fro movement of the bob. The time taken to complete one oscillation is called as time period. That is when the bob is in A position, when it moves to bob B, when it moves to C and when it comes back to A position. This is termed as one oscillation. And the time taken to complete one oscillation is known as time period. So I have taken a phone to be used as a stop clock, length of this, and now let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9 and so the time taken to complete 10 oscillation is 14 seconds. So I have reduced the length. Now let's look. How much time does it take to complete 10 oscillations? So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the time taken to complete 10 oscillations is 11 seconds. So when we calculated first, it took 14 seconds. And when I reduced the length of...
Good morning friends. Today we are going to see whether the pressure depends on density and depth of the water or the liquid present in it. So we are going to see whether pressure in fluids depends on density or depth. So I have a bottle filled with water and I have marked 3 points in it. And first point is of 14 cm, second point is of 10 cm and third point is of 5 cm. So I have made a hole in it. See, I will show you. This is the first hole. So I am going to open this hole and mark the point. So this is the water depth covered by leaf. So this was the point that we took earlier. The water from here fell here and the point I have marked here. So we are going to do the second one, second part of this. I have put a hole in it and the water is not coming here because I have closed this and there is no pressure. The outside pressure and the liquid pressure is same. So I am going to open and the water will come from here. So as you can see, this is the depth, this is the distance covered by it. So this was the point that we took from the second point and this is the other side I have marked here. And we are going to open the third point and here I have put the third point and we are going to open the gap and the distance. So this was the depth, this was the distance covered from here to here and this is the point that I have marked. And we can see clearly, this was the first thing. So the pressure from here or the force that is exerted from this bottle reached this point, only this point. And the second point was here and the third point was here. So as we can see, as the depth increases, the pressure or the force increases, which means that we have given the same area. My compass also has the same area. So this all has same area. So the force only differs. So as the depth increases, the force increases, which means pressure increases. So now we are going to see whether the pressure depends on the density of the liquid. So I have a bottle here and I am going to pierce a hole of 8 cm from the bottom. So I have pierced the hole. So I am going to first fill this water with water, then with oil. So I am going to fill this bottle with water. So I have filled this bottle with water and here is the hole. So I am going to make the water come out. So as you can see, the water is here. So I mark the question. So this is the point. So I am going to mark it. So I have marked the distance from here as here. This is the point. So I have marked it vertically, horizontally from there. So now I am going to fill this bottle with oil and see the distance. And I am saying that the oil will have less distance because we know that we have proven in the theory that H equals and pressure equals to H rho G, height into density into gravity. And we know that the oil has less density than water. So we know that the oil will go less distance as the pressure is small. So I am going to prove that. So I have filled this bottle with water and oil. So the water was also in the same length. So I am going to open this and we'll see the distance from here. And as I said earlier, the oil will travel less distance than the water because the oil has less density. So the oil is not moving. Oil is still. Oil is seeping to the walls of the container. So this means that oil has so less density that it affects the pressure. So I put oil has traveled zero, or we can say it has traveled negotiable distances. That means the density affects pressure. So if density increases, pressure increases, and density decreases, pressure decreases. This means that density and pressure is directly proportional. And this is the same case for depth also. Thank you.
Hello everyone, my name is Nihita Saikumar. Today I would like to demonstrate the principle behind Newton's cradle. Newton's cradle is an apparatus named after the very famous scientist Sir Isaac Newton. It demonstrates a scientific idea called momentum. Momentum is the force of an object as it moves. When you swing one of the marbles on one end, it collides with the other marbles. And the force of that collision travels through each of the other marbles until it reaches the last one, which swings upward. When the marble swings back down, the force travels through the marbles again. This is a demonstration of a scientific principle called the conservation of momentum. This principle states that when two objects collide, their momentum before the collision equals their momentum after the collision. In Newton's cradle, the force of collision travels through each of the balls until it reaches the last ball, which swings up. Momentum is also directly related to the mass of an object. Here I have used beads, which have very little mass and therefore their momentum is not very strong when they swing. Density is a measure of the amount of mass per unit of volume. Denser objects have more mass. The more mass an object has, the stronger the force of momentum will be when it swings. This executive ball clicker consists of 6 beads positioned to just barely touch one another. When a bead on one end of the cradle is pulled away from the others and then released, it strikes the next ball in the cradle, which remains motionless. But the ball on the opposite end of the row is thrown into the air. Then swings back to strike the other balls, starting the chain reaction again in reverse. How does Newton's cradle work? When the first ball of Newton's cradle collides with the second, the first ball stops, but its momentum isn't lost, just transferred to the second ball, then the third, then the fourth, until it reaches the very last ball. You witness this conservation of mass as the last ball swings into the air with nearly the same momentum as the first ball. Thus, if two balls are lifted into the air on one end of the device and released, then the two balls on the opposite end will swing in.
Jimmy of class 9B. Today, I am going to demonstrate an experiment to prove the Newton's third law of motion. For this experiment, I am using a string, a paper cup with a hole in its bottom and attached to a straw using a tape. I am also using a balloon. Here, in this experiment, I have taken a long balloon. Any type of balloon can be used for this experiment. Now, I have tied one end of the string to a chair and I am going to insert the other end through the straw that is attached to the paper cup. Now, I am going to tie the other end to another chair. mouth of the balloon through the hole. Now I am going to blow it up. Now what will happen is that when I release this, the air will rush out and that will be the action. So as a result, there will be a reaction and that reaction will be the cup moving forward. Now I'm going to release it. Now as you can see, when the air moved backward or air rushed backward, the cup moved forward. This proves the Newton's third law. Every action has an equal and opposite reaction. Thank you.
Hi all, I am Vaishnavi PJ of class 9S and today I am going to demonstrate the laws of reflection of light. So, the materials required are a plane mirror, a protractor, laser and the screen. The screen acts as a white background and it is made by wrapping a A4 size paper on this box. The first law of reflection states that the incident ray, the reflected ray and the normal lies in the same plane. This laser is red colored. We will get better reflection in dark, so let's turn off the lights. So let's keep the screen like this and in front of the screen we can place the mirror. This is the x-axis, this is the y-axis and this is the z-axis. The ray of light coming out from the laser is called the incident ray and the ray reflected from the mirror is called the reflected ray. The point at which the ray of light is incident is called the point of incidence, and when we draw a line perpendicular to the point of incidence, then it's called the normal. Thus we can explain and prove that the first law of reflection, that is the incident ray, the reflected ray and the normal lie in the same plane, is true, and this happens in the xy plane. The second law of reflection states that the angle of incidence and the angle of reflection are equal. So for that, let's keep the protractor like this. To prove the second law of reflection, that is the angle of incidence and the angle of reflection is equal, let's allow a ray of light, that is the incident ray, to pass through 50 degrees. Then it passes to the point of incidence and get reflected. This reflected ray also passes through 50 degrees. That can be clearly seen.
Hello everyone, I am Devadatta of Standard 9S. My experiment is a simple circuit. A circuit is a path through which the electricity can flow. This is a simple circuit consisting of three components: switch, battery and bulb. The switch represents a key. When the plug is pulled out from the key, the circuit becomes opened and the electricity does not flow. Similarly, when the switch is off, the circuit is open and the current does not flow. When the plug is put back into the key, the circuit is closed and the electricity flows. Similarly, when the switch is on, the circuit becomes closed and the current flows through it. For current to flow from a battery, it has to move out from its negative side and pass back through its positive side. Here what I have built is a closed circuit. For electricity to pass, we need a closed circuit. The electricity consists of small negatively charged particles called electrons. When the switch is on, the electrons start moving around from the battery all the way through the wires to the other end of the battery. Along its way, the electrons pass through the bulb, which causes the bulb to glow. Here, one wire is connecting the switch and the bulb, while the red wire from the connector which is attached to the 9-volt battery is connected to the switch, and the black wire is connected to the bulb. Thank you.
Hi everyone, my name is Nivedaya. I am of class 9S, roll number 17. Today I am going to do an experiment related to how to find the relative density of a solid which is insoluble in water. As we all know, relative density is the ratio of density of a substance to the density of water at 4 degrees Celsius. The formula to find relative density is density of substance by density of water at 4 degrees Celsius. Since relative density is a pure ratio, it does not have a unit. So now I am going to do an experiment to find the relative density of a solid using Archimedes Principle. Now I have took a thread and tied it to a stone and make a hook at the end of the thread and attached it to a spring balance. Now the apparatus is ready. Now the weight of the stone is shown as 225 gram when it is placed in air. Now I have took a beaker filled with water and slowly introducing the stone into water without touching its walls and bottom. And now the weight of the stone gets decreased to 150 gram from 225 gram to 150 gram. Now when the stone is took away from water, the weight is again 225 gram. So the weight of the stone in air is 225 gram, weight of the stone in water is 150 gram. So the loss in weight is 75 gram. So to find the relative density, weight of the stone in air by loss of weight in the stone. Weight of the stone is equal to 225 gram by loss in weight is equal to 75 gram gives the relative density as 3. So in this way we can find the relative density of a solid which is insoluble in water.
Good morning, I am Rishikesh S of class 8S. Today I am going to demonstrate how to draw the magnetic field of a bar magnet using an experiment. First, draw north-south directions using a compass. Now, take the bar magnet and place it on the paper and check whether the north pole is facing the north of the magnet. Now, keep the compass towards the north pole of the magnet. Now, put a dot on this paper where the north pole of the compass is pointing, and again place the compass on this point and draw a point. Draw till we reach the other end of the magnet. We will get a figure like this. After continue drawing, we will get a diagram like this. Do the same procedure on the other side of the magnet. Now, place the compass on the north pole of the magnet. Now put a point where the north pole of the compass is pointing. Again put a point like this and draw a line like this. Again put a point. Hence we will get a figure like this. After continuing drawing, we will get a diagram like this. Do the same procedure on the south pole as well. This is the figure of the magnetic field of this bar magnet. This is how to draw the magnetic field of this bar magnet. Now I am going to demonstrate an experiment based on the mapping of magnetism. The things needed for this experiment is iron filings, bar magnet and a cardboard piece. Scatter some iron filings over a cardboard and gently place the bar magnet and tap gently. We can notice some magnetic fields. These magnetic fields are almost same which we draw. The reason is due to the magnet. The iron filings get magnetized and form up curves like this. These curves are called the magnetic field lines.
I am Amit Shivkumar of class 9. Today, as a part of the science project, I am presenting my video. My video is based on the chapter Nutrition in Biology. I have done a project on garlic. The aim of my project is to illustrate the wonders of garlic by detailing its nutritional and antibacterial effects. Also, I will be demonstrating how to grow garlic easily at home. Firstly, take a bunch of garlic, then place them in a container, then cut its top portion. Then we should pour water in the container such that its top portion is not submerged and its bottom portion will be completely submerged. And in about a week or so, the sprouts will start to come. Then it will be like this. The roots will also be coming. When the sprouts come, we need to take individual clove and place them in a pot filled with mud. Then we should water it regularly. And in about 7 or 9 months, the harvest of garlic should be ready. Garlic contains vitamin B6, vitamin C, manganese and traces of other vitamins. It also has sulfur compounds, which is very good for our health. If taken in the proper quantity, it can be used to prevent common illness like common cold, flu. It can also be used to prevent indigestion. Now let's talk about its antibacterial effects. And because it contains sulfur compounds, it can be used as a very cheap and safe insecticide. If used in the proper quantity, it can be used to control crawling creatures and most of the insects. So this is how I made my garlic spray, and I'm gonna spray it here. As you can see, there are a lot of ants here. And when I spray it here, after some time they will be gone and they won't come back.
Respected teachers and my dear friends, I am Anand Muhammad N of class 9s. Today I am going to demonstrate the test of glucose. Glucose has the molecular formula C6H12O6 which gives sweetness. The test of glucose is important for us because we have to test it on our urine which gives an indication of the disease diabetes. For the test of glucose, we need these two items. First is the Fehling solution. We can purchase this in the laboratory as Fehling solution A and Fehling solution B. When we combine this, we will get the normal Fehling solution. Then we need this test tube. Today I am going to take these two products, the glucose, actual glucose, which gives a positive result. Then I am going to take the next product as sugar, which is a sucrose, which is made by glucose and fructose. This won't give a positive result. Now I am going to demonstrate the test. At first I am taking the test tube, some glucose. I am pouring the Fehling solution A, which is a light blue color. Then I am pouring the Fehling solution B. Look, now it is a dark blue color. We can see that it changed to a brick red color. Now let's test with the sucrose, our sugar. I am taking some sugar. Then I am pouring the Fehling solution A, which is a light blue color. And I am taking the filling solution B, which gives the dark blue color. So I am going to conclude the experiment by saying that if we add glucose to a filling solution, it will change to a brick red color with a precipitate. And if there is no glucose present, the filling solution won't change and it will remain the dark blue. I hope you all understand this experiment. Thank you.
Good evening, my dear teachers and friends. Today I am standing before you to demonstrate the action of diaphragm during breathing. So now we can go in detail about it. Here I am having a bottle which is cut in half and with a straw attached to it through a hole, and inside the straw I have two balloons attached to it, and here I am having a balloon attached to this stretch here, and in this experiment this straw represents the trachea and these two branches here it will represent the bronchioles. These two balloons here it will represent the lungs, and this rubber sheet it will show the diaphragm, the action of diaphragm while breathing. Okay, now during inhalation what will actually happen is that the ribs it will move upwards and outwards, and during when as a result of this the external intercostal muscles it will be stretched between them, and the internal intercostal muscles it will be relaxed. The diaphragm, which is this sheet, which usually remains arched upward at the base of the lungs, it will contract and will flatten into an almost horizontal shape. Now, and during which, and as a result of this, the volume of the thoracic cavity increases lengthwise, and the pressure inside the pressure inside the abdominal cavity will increase. The abdominal muscles will be relaxed, and the abdominal wall it will move outwards, leading to the increase in the volume of the chest cavity lengthwise and the decrease of pressure. And as the volume in the lungs is decreased, the volume of the pressure of the atmospheric pressure is higher than this one, so it will rush in to equalize the pressure. Hence, like this, it will be happening like this. So when the diaphragm it will remain in the horizontal shape, the air will rush in to equalize the pressure inside the lungs. Okay, now we can go on to exhalation. So exhalation means it is the reverse of all the activities that take place during inhalation, during which the ribs which moves upwards and outwards will go backwards and downwards. The diaphragm which has been contracted and flattened into a horizontal shape will change back into its normal halved shape like this. Now, during the time which the external intercostal muscles in the previous case which got stretched, now it will be relaxed, and the internal case which got stretched, now it will be relaxed, and the internal intercostal muscle will be stretched between them, and during which the air, if you breathe out forcibly as natural in normal conditions, then the internal intercostal muscles will contract, which will cause further contraction of the rib cage to expel out more air. Now I will show a demonstration of this. So now I am having a bottle here. So now when I push this rubber sheet downwards, the air is rushing in to equalize the pressure inside the lungs like this, and when I leave it, it is going back to its normal shape, which is arced upwards like this, which is causing the air to expel out like this. Thank you.
Hi everyone, my name is Akita, and today I am going to do an experiment to prove that carbon dioxide is released by germinating seeds during respiration.
I have taken two flasks named A and B, and I have placed some wet cotton, and also in flask A I have kept germinating seeds, and in flask B I have kept boiled dead seeds, and I have added a little antiseptic such as formalin.
So after a few days later, we can see these much changes, because here we can see the seeds have been germinated, and here there is no special change because they are boiled dead seeds and we have added formalin. Now I'm going to tilt this flask A and flask B into a test tube which is containing lime water. So I'm going to tilt this flask. So here we can see the lime water is turning milky. So here we can see the lime water has turned milky because germinating seeds produces carbon dioxide during respiration, and when this carbon dioxide passes through lime water it turns milky. Now we are going to tilt this flask B into this. So let's look what is happening here. So here the lime water is not turning milky. So when I tilted flask A into the test tube containing lime water, the lime water turned milky. But this is the lime water which I used for testing flask B. So here we can see there is no change in lime water's color. The lime water didn't turn milky. And it was boiled dead seeds. So this is flask B's lime water. I think you have noticed the changes when I tilted flask A and flask B into the test tube containing lime water.
Hello everyone, I am Adri S. Davidson of class 9S. Today we are going to do an experiment to demonstrate the presence of starch. The materials required are test tubes, iodine solution, plain water, starch water and some rice water. Now I've taken some water in a test tube. The principle behind this experiment is that if starch is present in the solution, then the color of the iodine solution will change from its original brown color to a bluish black color, whereas if starch is not present, then the color of the iodine solution will remain the same. I'll add a few drops of iodine solution to this test tube and let's see what happens. You can see that the color of the iodine solution remains unchanged as this water does not contain starch. Now let us repeat the experiment with some starch solution which I prepared by adding a bit of starch powder to some water and then boiling it. Let us add the iodine solution. Now you can see that the color of the starch solution changes into a bluish black as it has starch content in it. Finally, let us again test this experiment with some rice water. I'll add this iodine solution to it. And you can again clearly see that the color of the solution turns bluish black due to the presence of starch in the rice water. Now let us compare the difference in colors of the two solutions. This is the plain water and this is the rice water, and you can clearly see the difference between the two, as in the plain water the color of the iodine solution has remained the same reddish brown, whereas in the rice water the color of the iodine solution has changed to a bluish black color. Hope you all understood clearly how to test for the presence of starch using iodine solution. Thank you.
Good day to all. My name is Jedidya Nananraju of class 9S. Today I am going to show an experiment to prove the presence of fats and oil in the food. For this we will need some piece of paper, walnut, groundnut and butter. Now let's continue. First we should take a piece of paper and a walnut, and we should rub the walnut on the paper, and you can see the oil in the walnut spreading on the paper. Now we can take a light and pass it through. Now you can see that the paper have become translucent. Now we can remove the light and keep aside the paper and take a new paper and some groundnuts, and we can rub the groundnuts on the paper. You can see the oil from the groundnuts spreading on the paper. Now let's take a light and pass it through. You can see that the paper has become translucent where the oil has spread. Now after this we can move on to the final one, the butter. For this we should take a piece of paper and a piece of butter. Spread the butter on the paper. Spread it like this. This shows that when fat or oil occupies the small pores in the paper, it makes the paper translucent. This proves the fat and oil content in walnut, groundnut and butter. And this is my experiment. Thank you.
A warm good evening to one and all. My name is Rida Rashid and I am from class 9S. Today I am here to explain the protein test. As you can see here, I have taken a small piece of boiled egg and kept it in a test tube. Now I will be pouring a few drops of diluted nitric acid, enough to immerse the sample of food. Next, I heated the test tube gently and noticed a color change, first from a white precipitate to a yellow upon heating. I cooled the test tube by placing it under tap water. After cooling the test tube, I added ammonium hydroxide and noticed the sudden color change from yellow to orange. So after doing this experiment, one would notice a sudden color change, first from a white precipitate to yellow upon heating, and then from yellow to orange upon adding ammonium hydroxide. Thus, it is proved that egg has protein in it.